Welcome to Infinity Cast, where we explore the frontiers of science and technology. I'm your host, Elion Quanta. Today, we're diving deep, literally. We're exploring the 95% of our ocean that remains a mystery, and the silent, autonomous explorers leading the charge. Joining me to navigate these waters is my co-host, Orin Strath. Orin, welcome back.
Great to be here, Elion. It's a topic that's as vast as the ocean itself. When you think about it, we have better maps of Mars than we do of our own planet's seafloor. It's a staggering thought.
It really is, and that's largely because the deep sea is one of the most hostile environments imaginable. We're talking crushing pressures, absolute darkness, and near freezing temperatures. So how are we overcoming these monumental barriers?
That's where marine robotics comes in. We primarily use two types of heroes for this story: ROVs, or remotely operated vehicles, which are tethered to a ship and piloted by a human, and the real game changers, AUVs, autonomous underwater vehicles. These are pre-programmed, untethered robots that act as our deep-sea scouts, running missions for days or even weeks on their own.
Untethered and on their own. That's incredible. So they're not just mapping, they're making decisions. What kind of technology allows them to, for example, map the abyssal plains with any kind of accuracy?
It's a suite of advanced sensors. They use sophisticated multi-beam sonar, which sends out a fan of sound waves to bounce off the seafloor. By measuring the return time, the AUV can build an incredibly detailed 3D map of the terrain. Think of it as a form of robotic echolocation, but on a massive topographical scale. This is how we've discovered everything from underwater mountain ranges to ancient shipwrecks.
And from an analytical standpoint, this data is invaluable. It's not just about creating a world map. It informs our understanding of plate tectonics, identifies potential geological hazards like submarine landslides, and can even pinpoint unique biological hotspots, right?
Exactly. That brings us to their other crucial role: ecosystem monitoring. These robots aren't just geographers, they're ecologists. We can equip them with a whole array of chemical sensors, high-definition cameras, and even environmental DNA samplers.
eDNA samplers? So they can detect the presence of specific marine life just by analyzing the water. That's a non-invasive way to take a census of the deep.
Precisely. An AUV can swim through a delicate coral reef system, monitoring water temperature, acidity, and pollution levels, all while taking visual surveys of the coral's health and sampling for the DNA of the fish that live there. It gives us a complete, holistic picture of that ecosystem's health over time without a single human diver needing to interfere.
So these autonomous explorers are mapping the unknown, monitoring the fragile, and giving us the critical data we need to protect our oceans. It seems the key to understanding our planet's inner space doesn't lie with human explorers in submersibles, but with their robotic proxies.
I think that's the perfect way to put it. They are our eyes, ears, and hands in a world we can't easily visit. And with advancements in AI, the next generation of these robots will be even more autonomous, able to identify new species on the fly, or decide to investigate a strange chemical signature without any human input at all. The age of robotic ocean discovery is just beginning.
A truly exciting frontier. That's all the time we have for today. A huge thank you to Orin Strath for shedding light on these dark corners of our world. And thank you for listening to Infinity Cast. Join us next time as we continue to explore the world tomorrow.